All righty, is this thing on? Yep. All right. So as I said, today we're going to chat about DevOps a little bit. Or more specifically, what I really want to cover off is how you learn how to go fast without tripping over the cables. And so my name is Peter Goodman. I'm one of them. I'm Piku on Twitter, Piku on GitHub. You can find my opinions and code around about there. As Ben said, I work for a company called PushPay. I'm based here in Auckland. PushPay, we're a payments platform. So we facilitate payments between people and merchants, is what we call them. And I've been there, it'll be 2 years in August, so about 18 months, 19 months, or whatever, I can't count. And in that time, we've grown from, I think it's about 6 or 7 developers up to like 27, something like that, and QA. And so that growth has been interesting, right? We've had to learn how to solve a lot of problems pretty quickly. Ben said I'm in the DevOps team. It's not quite true. We kind of renamed ourselves with a site reliability engineering team. The reason we chose that is actually DevOps isn't a great word for describing a team. We'll kind of find out why. But what we do as a site reliability engineering team, which is a term we nicked off Google, by the way, is that we facilitate or we help other teams deploy their stuff, get it into production, and run it. All right, so we help them do that, and we help them do it so they can move fast and do it more safely. OK. So what about this term DevOps? Where does it come from? Well, it's kind of started when we were doing the agile development revolution. We started to kind of realize that we needed to be able to respond a lot more quickly to our customers' needs. And so that was working its way through the software industry, and the way we built software kind of changed. And a lot of people started to jump on continuous delivery. All right, they realized we can push this a little bit further, and we can try and deploy more often. In 2009, at the O'Reilly conference, John Allspaw and Paul Hammond did a talk called 10 plus deploys per day, Dev and Ops Cooperation of Flickr. Now, at the time, 10 or more deployments per day was a lot, like a lot. And the reason they were able to do this, they said, was because they had this cooperation between their development and operations teams. And so Allspaw being ops and Hammond's dev, and they kind of were able to pull these two teams together so they could work together and then ship code more often. All right. In the same year, a guy called Patrick Dubois set up a conference. It had its first meeting in Belgium. And he called it Devops Days. He basically coined the term. So a lot of people have been talking in Google groups already. They've had the same similar ideas. They got together, did a conference, called it Devops Days, became a Twitter hashtag, and it turns out things on Twitter grow really quickly and become things quite quickly. So Patrick Dubois wrote an article, a blog post about a year later. And he tried to define what it was that he thought the DevOps movement, as he called it, was all about. And he said, look, we were a bunch of people trying to solve these problems. And the first thing I identified was there was a fear of change in the industry. And why was this? Well, at PushPay, we have a term that we use for what we're going to ship. So the difference between what's in production and what's getting shipped to production is called the delta. We like that delta to be small. We like to do it very often. And that allows us to manage risk. If you deploy every couple of days, weeks, months, longer, what you'll find is that delta gets really big, right? And it turns out if you investigate the issues that you have in production, you can always track it back normally to a change that happened, right? And so being able to identify which change was the problem, it gets a lot more difficult because your delta's a lot bigger. Bless you. So we try to keep this small, and we kind of try and do it more often. If you think about the development and operations teams and how they relate to change, development really are the agents of change, right? They want to build features and get them to customers' hands as soon as possible. Operations, on the other hand, are responsible for looking after the stability, reliability, availability, all of these types of things. And if you were naive, you'd say one way to do that would be to limit the amount of change that you put through the system. And so what we're saying here is their goals aren't well aligned. And DevOps really is about trying to align those goals. So we have this fear of change. We have these risky deployments because if we're not doing it that often, we're not that good at it. And we may have a lot of manual processes involved, and a lot of human error can enter into the equation, and things go wrong. The other thing that's quite interesting that happens is the WOM. The WOM is whenever an issue happens in production, and you will find an operations person, let's say, will investigate it and say, this looks like a software problem. Nothing on our side died, so I'll take this and I'll go to a developer and I'll say, hey, there's a bug in here somewhere. I want you to look at it. The developer will go clackety-clack, 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 clackety-clack. And he'll say, works on my machine. And I don't think anybody says this apart from ironically anymore, but it's an attitude that my job was done when I was dev complete. It's somebody else's responsibility now. They look after it from now on. And so this is the singular worst thing you can say to an ops person that gives you a ticket. They really don't give a flying that that it works on your machine. What they really care about is that it's broken for some customer. All right. The other thing is all of these problems create silos. They reinforce the seams between development and operations, and they mean they can't work well together. They have disparately aligned goals, and they have a cultural problem. So what do we do about it? How does DevOps help? To me, there's a lot of misconceptions about what DevOps does. A lot of people have been trying to solve the DevOps problem. And to me, some people go out and they'll say, look, we're going to hire us a DevOps. So they'll go out and they'll put out a job ad. We're looking for a DevOps. We don't really know what they do, but we want one. And they'll say, well, we want to create a team, a DevOps team. To me, you can't solve the silo problem between development and operations by putting a team in between them. That really doesn't make sense to me. And there's no such thing as an end-to-end DevOps solution, despite what some vendors might tell you. So is it about suite tools? Well, not really. They're not the goal. They're definitely part of the story, but they're not the goal. Is it about free access for everybody? This is an interesting one. So what some people do when they try to go on the DevOps journey is they just say, look, all the developers have access to all of the machines and all of the data, because they'll be better than ops people, surely. I've been exposed to a lot of ops recently in the last couple of years. It's not that easy. We work in a PCI, right? We deal with payments, we deal with money, we deal with credit cards. It's harder to justify us having all of our developers with access to production. That gets difficult. Another thing that's interesting, we run quite a monolithic solution. Our architecture right now is quite monolithic. That suits us. There's a lot of advantages to it. There are some disadvantages. One of the disadvantages is it's really hard to assign a single issue that happens in one part of the application to a single team. And so we have a core team. It's really a group of people spread across sales, as we call our ordinary project teams. And those people all have access to production. But there's a further story here, which is if in order to diagnose your problem, the issue that you're having in production, if to do that you need to log into a production system, you need to run a script somewhere, you need to access to the database to go poking around, then you've failed. All right. To diagnose a problem, you shouldn't need to perform open heart surgery. All right. So it tells you that you don't have the right telemetry, you don't have the right tools, and you should look to change that. Likewise, it's not about automating absolutely everything. We have a bunch of manual processes. It definitely helps. Automation will make you go faster, or help you go faster. It'll reduce risk over time, but it's not the answer. Likewise, it's not microservices, it's not Docker, it's not containerization, it's not magic or unicorns. And so this really doesn't help you, right? There's a kind of fundamental problem here in that it's very difficult to define, which is why there's a lot of difficulties in people coming up with an idea of what DevOps is. To me, it's actually just an attitude. That attitude to me values lowering the risk of change through tools, culture, and communication. All right? The process that you have in your organization aren't going to make you help you go faster. They're not going to help you implement continuous improvement. It's the values that you have that allow you to do that. The values drive the tools, and the tools drive the process. Right? If you put the process at the front, it's wrong. All right. The values that you should have are, let's try and do this more often. Let's try and reduce the risk. All right. So how do people start? A lot of people start on this kind of journey in where continuous delivery starts and continuous deployment. So they'll automate their deployment. And this is an amazing place to start. It's really good. You can get a lot of benefit from just automating your deployment. But let's say you do your deployments every couple of months, and let's say they're big. Let's say they have downtime. Right? Let's say there's like key people that know everything about it and not everybody else does. You can't just send a team off to kind of automate that and say, cool, we'll just swap that over, the next one, because you're just exchanging one really horrible set of risks for another really horrible set of risks. All right, so what you do, you actually piecemeal it, right? You're going to do a little bit at a time. You're going to figure out what it is you need to automate. How do you figure that out? I would argue that the key to doing DevOps and to do it safely is to make all that hidden shit visible. All right? When you think there might be an intermittent bug going on, make it more visible. It'll help you figure out how intermittent it is and what you can do about it. When you want to protect people from the risk of the actions that they're performing, right, make it more visible. Right. When something might be slowing you down, again, make it more visible. Everybody is responsible for quality and stability in your organization, so that visibility leads to shared understanding, and that leads to better solutions and less risk. So when I talk about visibility, for us, a lot of that visibility ends up here in Slack. Slack is does anybody not know what Slack is? Slack is an enterprise chat system, and it allows us to communicate asynchronously in really constructive ways using GIFs and emojis. And so the reason we like Slack is because we can start to intersperse all of our different types of communication into the same place. All of our notifications and things can come into context, and we can start to follow the threads of what's happening in the system, as well as what people are doing. And it's part of our culture. So if we think about culture, right? If we think about culture in our organization, what you need to be able to do DevOps safely is continuous improvement, right? That's how you keep changing it. How do you free your people up to be able to continuously improve and move fast? So I was doing a previous genesis of this talk, and it was kind of like a development operations thing. It was kind of like, these people hate each other and Punch and Judy, and it was kind of a bit weird. And I took it to our VP of engineering, Josh Robb, and I said, hey, I'm doing this talk. What do you think? I showed him the slides, and he said, yeah. He said, to me, it all starts with Blameless Post-Mortems. I'd done a few Blameless Post-Mortems by this time, and I had no idea where this fitted in. So I decided I'd ignore him and go home, as you do. So I got on the bus. I started to go home, and I happened to be listening to a podcast. In that podcast, they were interviewing a guy called Sidney Dekker. Now, Sidney Dekker's work is credited for a lot of the thinking that inspired people like Etsy to do Blameless Post-Mortems. And so what is it about a blameless post-mortem? Well, if in a traditional post-mortem, something happens in production, you may decide sometime later you'll have a post-mortem and you'll do something about it. And what you go doing is you go looking for a single root cause, right? You do that root cause analysis. Let's find that root cause and let's burn it with fire. If you go looking for a single root cause, what you'll find is you'll probably find a single action, right? And that single action will have a name and a face, and what you end up with is blame. When you end up with blame, you ruin continuous improvement, because let's say Dave or Melanie clicked the wrong button, they ran the wrong script, they did something like that. And you say to them, you suck. And then what are they going to do the next time you ask them to perform a change, or the next time they need to do something? They're going to avoid it like the plague, because they don't want to be blamed for it again. In fact, that fear of change that we talked about earlier is actually the fear of blame. So you've got to eliminate blame. Now, Sidney Dekker, he wasn't an IT or anything. He's a psychologist. He studies safety engineering. Why do planes blow up? Why do oil rigs go on fire? Why do doctors have malpractice suits? That sort of thing. And so a lot of the thinking that came out of that industry fed into this idea of blameless post-mortems. So instead of looking for a single root cause, what we do is we look at the timeline of events. Right, those timeline of events allow us to see from a perspective of the person making the changes and doing the actions what information was available to them at the time. If you can imagine, it's like somebody walking through a maze. In a traditional post-mortem, you're the person looking down at them and going, well, you should have turned right there. That was pretty dumb. In a blameless post-mortem, you're taking the perspective of the person walking through the maze. Right? You really want to see what choices they had available to them and how obvious they were. And it turns out you're going to end up with a bunch of mitigations rather than one root cause. And all those mitigations will lead to better solutions. And the reason is because you can provide people more information. Like, we can put a great big sign saying, turn right. And that may take the form of metrics and a bunch of other things that we'll discuss. The other thing that's really interesting I find here is, like, if in operations people, perform actions on servers, and they do a lot more kind of manual work, initially, or they used to. And so, what do we call it when an operation person screws up? We call it human error. What happens when somebody in software screws up? What do we call it? We call it a bug. Because that bug organically grew inside of our system. I was just busy here kind of like writing code, and then this thing started growing over here. We fed it after midnight, or we poured water on it, and all of a sudden we have a bug, and we'll fix the bug. So in the software industry, we've gone some way to solving this problem. We need to push it a little further. All right. So we assume that everybody comes to work to do a good job. All right, we hire good people, so it has to be the process. Find the problems in the process, find the problems in the information available to people, and help them, right, rather than blame them. Sometimes it's called the bad apple syndrome, the theory that there's a subset of people, a small set of people are responsible for a large percentage of the problems. Sidney Dekker says reprimanding bad apples may seem like a quick and rewarding fix, but it's kind of like pissing in your pants. You feel relieved and perhaps even a little warm for a while, but it gets cold and uncomfortable, and pretty soon you look like a fool. So our postmortems are public within the company. They go in Confluence. We drop them into a channel called the morgue inside Slack. Everybody can visit the morgue. Everybody can look at the cadavers. And everybody can contribute. All right? So everybody can say, hey, look, I think we should have done this. Or, if we're going to do this thing over here, we should probably tell people that, don't click on this or whatever, right? And you got to think, right, so you're doing blamelessness. You've just removed accountability, haven't you? So no. What you'll actually find is people are more likely to give their account, right, accountability. And what they'll do is they'll say, actually, I made this decision, I did this thing. If I had that information, I would have made the other decision, and I wouldn't have done that thing, that sort of thing. So it's really good. The results are actually really positive. And what you find is you've freed your people up to continuously improve. This is where it starts. You want to do these postmortems as close as possible to the original learning. And if you want to find out the details of exactly how we do this, Josh did a talk, had a conversation with Thiago on Devops Dimensions, which is Channel 9 MSDN show. You should watch that. It's really a lot of detail about how we actually go about this. All right. So we mentioned metrics. Most of our metrics, we use StatsD. StatsD is like an on-the-wire protocol from Etsy that allows you to send metrics over the wire. We use Librado, which is kind of graphing as a service. We store all of our metrics up there. It's like a time series database with graphing tools on top. And we just send all our stuff to them. We send them 16,500 metrics every 20 seconds. It's quite a lot of stuff goes up there. And sure, we have what I call ops metrics, which is things like CPU, memory, disk, I/O, all that type of stuff. We have code behavior, which is things like how many messages am I putting in the queue? How many am I taking off the queue? How fast am I doing that? How many SQL queries am I running? How many rows am I returning from those SQL queries? Business value. For us, that's payments. How many payments are we making? What are the value of those payments? And how does it affect people? How long is it taking for them to render? How many error pages are they seeing? All that type of stuff. It helps to put vertical deployment markers in there because it turns out inflection points around a deployment are normally a sign of something that you did. The seminal kind of talk on metrics is by Coda Hale. Coda Hale at the time was working for Yammer, did an amazing talk called Metrics Everywhere. he makes two really, really good points. The first one he says is mind the gap. And what he's talking about is he says mind the gap between how you think your code's going to run and how it actually runs. Now, I've been writing code for a little while. I don't know, a long while actually. And the thing about it is I'm constantly surprised by what my code does. Now, I think that's a shared thing. I could be wrong. I could be shit at it. But given that I think it's a shared thing, why would you not measure what your code's actually doing in production? It seems mad not to. It seems negligent not to. Second point that he makes is your code only has business value when it runs for a customer. You think about that. The inverse of that is your code has no value unless it's running for a customer. So the code that you have sitting in a feature branch that's not merged has no actual realized value for your business until it's running for a customer. It has potential value, but not actual value. We use feature flags quite a lot. Feature flags allow us to keep stuff moving through the pipeline really quickly. We love them. We can flip stuff on in QA and off in prod, that sort of stuff, and we get a lot of benefit out of it. But that code you have sitting beside a feature flag that's not flagged on for your customers, not running for your customers, has no business value. The stuff that you no longer run, just delete it. There's no value. So moving on, how do we make architectural decisions? We don't have a grand, high, ultimate architect. We don't have architects. We don't have an architecture team. We don't have a Druid council. We have kind of some graybeards that have been around for a while, but kind of, talk a lot more than some other people. But every developer in our organization is responsible for moving the architecture forward. And that seems pretty hard to manage, but it's not. What we do is guilds. So if you've ever seen the Spotify videos, they talk about this concept of guilds. So you have your normal teams, what we call cells, and then you have open guilds that anybody can join. They can go to the regular meetings, and they can join the Slack channels, which are open. And if you want to make a change to the system, you drop it in there, and you say, hey, I'm thinking about doing something a little bit of a different way. If enough people agree, then it becomes a thing, and it's done. But then how do you stop the architecture getting out of control? Surely there has to be somebody that oversees all of this. Nope. Because we all recognize that it's getting out of control, and we all have a discussion about it. Sure, there's somebody who makes decisions if we all disagree, but that's different. For operational changes, sometimes you don't start with source control, so you may have some manual processes that need to change. Let's say you need to change the backup strategy. We use a decision register for this. It's just a Confluence page that kind of talks about why, talks about the risks, talks about any runbooks you need to do, that sort of thing. Drop it into public channel. everybody can see it. It's visible to everybody. We can all comment on it. It's that shared responsibility. All right, let's talk about the boat or the train. This is how we get code into production. When I first joined, there was one or two people, I think, that could push to production. And so if you wanted to get your stuff into production, you had to talk to them. It had to be reviewed and all that kind of stuff. That didn't really scale, obviously. So then we decided everybody should be able to push to production. But we had to train everybody how to push to production, so we took it in turns. And you became the ship it captain for the day. It was cool. It was cute. We had a hat. We had a captain's hat. Actually, it was kind of filthy. But so we had this kind of, let's round robin the thing. Then we had cells, because we were growing again, and now cells responsible for the week. But the problem with that is there's all this hidden friction and queues that you don't see. Right? There's people waiting, monitoring, just thinking, oh, I'm going to try and land my stuff here. No, I'll hang back. And you don't know what's going on there. So we changed this model. What I'm going to show you is kind of what we do right now. It probably won't be doing what we do next month. Probably may not fit your business, but it's just a snapshot, right? So it all starts with a pull request. You open a pull request by pushing a feature branch. Pull requests only last a couple of days. Everybody can see the pull requests. You can have a discussion early before you've overcommitted. And when you're ready, you say, look, this pull request is ready for review. You put a label on it. That label triggers a bot to put a notification into your cell Slack channel to say, hey, this thing's ready for review. Somebody should come look at it. And somebody does. And you have a conversation. All right. Oh, no, you should have done this. Tabs, spaces, whatever. And you end up kind of coming to agreement, and that's ready to land. At this point, there is something worth mentioning. This is within a cell. We have another concept we do, which is an inter-cell review bot. So it's asynchronous. Once this thing's been merged, we'll pick somebody randomly in another team to come look at it. And this serves a bunch of purposes. One of them is it shares learning. All right. So if one team have discovered a new way of doing stuff, it kind of spreads amongst the other teams. The other thing that it does is it stops these standards appearing within a team. Standards that aren't intentional, they just happen to be how those guys do their stuff. Now, the other, if you think about these types of accidental standards, like one person, maybe they're under pressure and decides, hey, I'm gonna change this. I'm gonna just do it quickly, I'll do it dirty, it's fine, it's this one time, nobody's around, and we'll just ship it. And then the next person comes along and says, I need to do a similar thing. I'm just gonna look at what they did because they're suffering from imposter syndrome. I'll just copy that. And then the next person, all of a sudden you've got an accidental standard and you're asking yourself, why the fuck do we even do it this way? It's crazy. And so this kind of cross-pollination is really good for us. It allows us to break down those silos between those teams like we talked about. All right, so it's good. It's ready to land. The person who's reviewing it says, hey, it's ready to land. They change the label. Another bot, same bot actually, will say, hey, here's a notification. It's ready to land. We're good to go. You can continue. These notifications, I didn't have time to change the screenshot. And this time it was called ShipBot. It's now called Bodie McBoatface. We have a bit of fun with some of our bots, as you'll see. But the other thing that happens here is that at this point, we reintroduce that WOM term, but we give it in a different context because we have a shared QA environment right now that kind of suits us for our size. It's kind of OK. We can manage it because we do other things to help. Now that that's a contended resource, you have a problem. People need to get in and out as quickly as possible. So what we do is we have a developer come to the QA, come to the developer's machine, and they works on my machine, test it. All right, gets the WOM seal of approval. Then what happens is when you get to the shared QA environment, you're really doing what I call carpet fitting. Because you've already picked the color, you've already cut it to size, you're really just kind of checking the seams and making sure it doesn't clash with the rest of the room. All right. And so it's good to go, right? You're ready to start shipping. We implemented an idea from Etsy, which is like a train that sits in the topic of, they use IRC, we use Slack. So it's a train that sits in the topic of your Slack channel. We have a ship it channel for this. We have a bot that we call C3PR. Yeah. And if you want to join, you want to ship something, you do .join, the bot will put you in a new carriage at the end. If you want to join with somebody else, like you've agreed you can ship together, it's kind of low risk, then you can kind of join with somebody else, you can form a new train, or expand the size of your carriage rather, and you're ready to go through. The people ahead of you will be pushing their stuff through, and the bot will say, hey, you're up. All right, you've got to the front of the queue, and are you ready? And you say, .ready. And the bot says to you, merge your changes. And so you're ready to merge. You hit the merge button in GitHub, and the automated process takes over. And it says, we're going to build it, unit test it, package it, and deploy it to QA automatically. At that point, we kick off a whole bunch of tests. We have long-running tests, third-party integration tests, Selenium-style acceptance tests, Babbage, which is our perceptual diffing tests, like, hey, like the screenshot before, the screenshot afterwards. We lay them over the top and we say, hey, there's a problem here. It kind of catches all those things from those CSS blind fiddling malarkey that you're doing. And you're ready to ship it, right? We used to force people to go and look at all these builds and know what they meant and match up the version numbers. We just pull it all into the same place so it's all visible. You get 5 green lights in this case and you're ready to go. And you're ready to ship. You hit one button, 2 minutes later, your code's running in production. That's it. You make sure the world isn't on fire. You type .ready, and the next carriage moves to the front of the train. All right, that's kind of what we're doing right now. And this has come out of spending time trying to find the friction and the hidden cues in our process and greasing the wheels a little bit. All right, so operational events, other things that we make more visible. We use Raygun.io. We absolutely love it. It's amazing. It shows us all of our exceptions. It puts them into a Slack channel, and we can go through them. We have many Slack channels for those Rayguns. We have very alarming for our production. We have barely alarming for test, merely alarming for our sandbox. We have app-errantly alarming for our apps. We have pixel alarming for those diff tests, and we have untypedly alarming for JavaScript. And so they allow us to kind of pick and choose what we're interested in, and then eventually we do get coverage, right? Everybody can see those things happening. Those vibrato graphs I showed you earlier, we put thresholds on those, and they will fire. Those, again, are notifications in the Slack. So we also use Sumo Logic. We absolutely love Sumo Logic for our logs right now. It's a SaaS product. It's kind of like Splunk in the cloud. You send them all your logs, and they just allow you to query them in crazy ways. So we can do scheduled queries that say, hey, look for these certain types of log entries, and like post into Slack if you see them. Like, there's been so many failed logins to that server, that type of stuff. And a lot of this stuff then feeds into PagerDuty. So PagerDuty is a way of it's an app that allows you to have a certain schedule of people on call, and then you can say, okay, when we need to tell somebody, we'll go and wake these suckers up out of their beds, and they can go fix it. Thing is, though, those PagerDuties are also posted into Slack. The reason they are is because we want that shared responsibility again. If I get woken up at 2 o'clock in the morning, I often come in, and somebody will pat me on the back and say, dude, that sucks. Here's a way you can fix it. All right. And that's really useful for us. The other thing we do with those PagerDuties is we try to provide as much context as possible. Be kind to the people that you wake up in the middle of the night. Try and allow them to solve the problems quickly or discount them quickly. What we're doing there is we're kind of optimizing for mean time to REM. Right? You want people to be able to get back to that dream sleep, that lovely sleep that they all like. No more tears, only sleep. All right. Sometimes it's not your fault, though. Brendan, one of our QAs, pulls in a bunch of really interesting security stuff, vulnerabilities, and they get automatically posted into a Slack channel. And we can emoji vote on them and say, no, they look good, I've looked at it, or no, death. If you don't know about this stuff, you're doing something wrong. Right? You really need to know about this stuff. Right? So find the sources. It's really easy to get like Twitter feeds, RSS feeds, stuff like that put into Slack. And it allows you to be able to raise the visibility of it. If you don't find out about these things within a couple of days of them happening, there's something going wrong. The other thing is third-party status page updates. So those go, like if you see a bunch of exceptions happening in your platform, it's really useful to be able to see, oh yeah, GitHub's down, or this like downstream email provider is down. And those things add context, and they allow people to be able to figure out what's going on a lot quicker in stream of consciousness that's coming out of the system. So hopefully it doesn't reach your customers. Hopefully you find it when it does. But if it does, then you want app reviews. We post those in the Slack channel. Our customer engagement team are active in there. We kind of talk to them. We can say, hey, you guys, these customers were affected by this thing. Can you go talk to them and see if they hate us? How your business is performing, we all like to know. We've still got jobs. But you got to ask yourself, right? Given all of this stuff, given that we know we can pull all of this information together, doesn't it all get just like a little bit too much? And yes, it does. Right? It can get a lot too much. It can get really horrible. But what's the alternative? The alternative is like ignore it, bury your head in the sand, hope that like stuff doesn't go wrong, and when it does, somebody as your customer will tell you. It's not really sustainable. And so what you really have to do is constantly tweak the balance between fatigue and ignorance. Right? What will happen is one of two things if you have too many alerts and too much noise in your alert system. Is that people will get burned out, or they'll retrain themselves to ignore stuff that could be important. And that's the worst one. Because nobody wants to have a post-mortem which is, yeah, we knew about it. It was like, it was ringing on everybody's phone. It was all over Slack. But, we kind of just ignored it because stuff's noisy. And so you've got to constantly tweak this stuff. When you do, we use those vibrato dashboards quite a bit. But those style of knock dashboards, those kind of like State of the Union or whatever, these massive big dashboards. They're really good, but you're not going to stare at them all day. Right? You need to bring that information to the people that are working on other things, right? So they can assess it individually. You can't just have people staring at this stuff. Some people put them on big TVs. We currently don't do this. It's kind of useful if somebody's walking past and goes, "Oop, that looks bad." But really, at that point, you should be putting in an alert. Sometimes there's too much noise. All right. Let's say we find something in production. We say, "Hey, we need to like notify people of this." We'll put it into Slack because maybe we didn't have the logs to figure out how big a problem was in the past. And you say, "We're totally blind to this. Let's put in a notification. We'll see when it happens." And then all of a sudden, it's just, it's happening all the time. This is a positive thing. You just find out it's a real problem. And now you can choose to discount it. You can choose to tone down those alerts quite a lot. But at least now you know where you're at. So to me, the key to doing DevOps safely is making all that hidden shit visible. Look for all of those things that are hidden away that one person knows and make them visible. That shared responsibility, that shared understanding leads to better solutions and less risk. That's what you're looking for. That's how you enable yourself to go faster and do it safely. All right, that's me.